Here are the essential derivative rules for exponential functions. So the derivative of e to the x is simply equal to e to the x. Now that's something you just have to remember. The derivative of e to the x is itself. And then the derivative of a to the x is equal to a to the x ln a, where a is a number greater than 0 and not equal to 1. Now this is also something you just have to remember. The derivative of a to the x is a to the x times ln a. Now if there's more than just x in the exponent, we need to use the chain rule. And that's for both when the base is e and when the base is a number greater than 0, not equal to 1. So there's a few examples of this. Let's say we have the derivative of e to the ux is equal to e to the ux times u prime. That's simply the chain rule. And then for when the base is a, the derivative of a to the ux is equal to a to the ux times ln a, all times u prime x. So with that in mind, let's go over a few worked examples together. So for example 1, if I were to tell you to find the derivative of e to the x, what would it be? Well, it would simply be e to the x as we discussed earlier. Let's try the next problem. If I were to tell you to find the derivative of 2 to the x, our first step here is going to be to apply the rule for a to the x, which we discussed earlier. So essentially here, let's write it down here actually. We can go 2 to the x. We need to apply the rule for a to the x. So here, the derivative of a to the x is simply equal to a to the x ln a. So for this here, f prime of x, or the derivative, is going to be equal to 2 to the x and then ln 2, since we're substituting in for 2. And that's our derivative. Let's try a third problem. For the third problem, let's say I were to tell you to find the derivative of e to the 3x. Well, firstly, let's just let u equal 3x. And then u prime, or the derivative of that, will be equal to 3. And now we can apply the chain rule. So the derivative of e to the u is equal to e to the u times u prime. So now that we wrote that out, let's just substitute back. F prime of x is equal to e to the 3x, which is u, times u prime, which is 3. And then when we simplify this, f prime of x is equal to 3e to the 3x. Let's try 2 more problems. Let's say I were to tell you to find the derivative of 5 to the 2x plus 1. Firstly, we can let u be equal to 2x plus 1, and then we can let u prime be equal to 2. So the second step here is to apply the rule for a to the power of u. So the derivative of a to the power of u is equal to a to the u ln a times u prime. So now we can simply substitute in. F prime, or the derivative, is equal to 5 to the 2x plus 1 times ln 5 times 2, which is u prime. And then when we simplify this, f prime of x is going to be equal to 2 times 5 to the 2x plus 1, all times ln 5. And that's our derivative. Let's try one last problem. Let's say I were to tell you to find the derivative of e to the x plus 4 to the x. So we're going to combine the two this time. So our first step is to differentiate each term separately. So the derivative of e to the x, once again, is simply equal to e to the x. And then the derivative of 4 to the x is going to be equal to 4 to the x ln 4. Now we need to just combine the terms. So f prime of x is going to be equal to e to the x plus 4 to the x ln 4. And that's the derivative. Now, a few key things to remember. E to the x is always its own derivative. For other bases, you need to multiply by the ln times that base, and then always apply the chain rule if the exponent is more than just x. I hope this video helped. Thank you.